GIS in Indiana, the practice of GIS in Indiana. I will let Jim take it away, and he's also got his cohort here, Kavya, and you'll be using this microphone when you come up.
Cool. So, question and answer time. How many folks in the room are map nerds? Awesome. How many are GIS practitioners? A few. I like this. This is amazing to me. I love it. Welcome. So hopefully I've got something for everybody when it comes to the practice of GIS in Indiana. But let me start with who I am and how I got here, because there are degrees that can be earned and received in the field of Geographic Information Systems. That's what we're talking about here. But most practitioners that I know of came to the field in much different ways than academically. For example, I started, actually I could take it back one further step, dropped out prior to my 4th year at Purdue, worked in a car wash for a few weeks. A friend said, come work on a construction survey crew. I said, I don't know anything about that. He said, that's cool, I'll teach you. So he did. So I sort of started down this field with that job on a survey crew. I spent some time at a manual drafting board with pen and ink on Mylar. Along the way, I worked for Ozaukee County in Wisconsin, keeping their plat map books up to date. I took a course at a technical college in Milwaukee that was computer-aided drafting before I knew a whole lot about that, and before a lot of people knew very much about using computers to do that chore. Along the way, I was the GIS administrator at Indiana Department of Transportation. I became a project manager doing data conversion for GIS projects, did a little consulting now and then, and until this past March the 1st, I was the state's first Geographic Information Officer. I'll talk more about that in just a second. Along the way, spent time in county government, state government, the university sector, which I'm happy to say is where I'm back, and a lot of years in the private sector. So here's what I want to talk about tonight. I want to talk a little bit about the governance of GIS in Indiana and how it's practiced, some of the projects that will give you a good idea of what it is we do day to day. I want to let you know that there are lots of benefits that we derive as Indiana citizens because of GIS and how we practice it in Indiana. A few lessons that I've learned along the way. I'm a quotes guy. I like quotes, and there's some observations and some values that I've gained from those that I want to share with you. And Kavya is getting to the meat in the sandwich. So she's going to talk about how we use Python to help automate a lot of things that we do at the Polis Center, where we both work in our day-to-day business. And then we'll hopefully have a little bit of time for questions and discussion at the end. So governance. You have a state statute that says, and that's the number there, that says, among other things, the state will have a Geographic Information Officer. Maybe I should pause just a second, and in a real brief way, I should not assume everybody knows what GIS is, right? So maybe I ought to explain that for a second. If you think about computer mapping, if you think about a database of attributes and a visual overlay or a bunch of overlays of graphics and links between those two so that you can query on the attribute side and see what shows up on the map side, or you can use the map and narrow down your attributes. They're joined together, so it gives it a lot of power for analysis and also for visualization. So we used to spend lots and lots and lots of money building data sets that were GIS data sets over and over and over. Someone finally said, our legislators said, let's get someone who's in charge that can be a kind of a central coordinator for the practice of GIS in Indiana. So the Geographic Information Office was born 7/1/2007, at least in statute, and then a couple of months later I was hired. So notice the qualifications here, which I think is really cool because it doesn't say politician's brother-in-law. It's actually got some things in there that you might want to to make sure that your Geographic Information Officer has in hand for that job. Here's what the state statute says in terms of the responsibilities. First of all, coordinate GIS efforts across the state so that all those expenses I was talking about, we can cut down on those and just try to do things once and share stuff. Integrate data, which means look around the state, see where GIS data exists, and pull it all together as best we're able to. Recognize that sometimes we need to create new data. For me, that means mostly building a business case and knocking on doors looking for funders. Distribute that data. That's huge because data that doesn't get exercised has really no value, right? Conversely, the more that we use a data set, the more value it delivers. And finally, the only one of these things that's strictly focused to state government is be the GIO for state agencies. The state statute also mentions the Indiana Geographic Information Council. This is a not-for-profit organization that is very helpful with trying to coordinate GIS efforts across the state. So we like to say we got them surrounded because I was inside state government, IGIC was outside of state government. We each could do some things and couldn't do other things, but together we were pretty successful. The first project I want to talk about is the statewide imagery program. So if you go to Google Maps, right, and I think Google calls it satellite data, but it's kind of that overview button that you can click. Look down at the bottom and you'll probably see some code words that say Indiana Framework data. That's because we built a lot of the data that shows up on the Google Map website when it comes to orthophotography. Orthoimagery is special photography. It's been processed so that we can measure across it, something you can't do with an ordinary photograph. So we did a project statewide in 2005. We used funds that were distributed as a result of 9/11. Everybody said, we got to get our act together. We got to get data in hand and be ready when things happen. We did a second one, 2011 through 13, using disaster recovery funds. And then this latest one that we're in the final year of is being paid for by state modernization funds. And it's administered through that Geographic Information Office that I was talking about. Here's what's being delivered. Leaf off, so it's flown at a time that leaves are not on the trees, so we can see what's underneath the trees, right, what's on the ground. 1 foot pixel imagery, so you're up in an airplane, you look out the window to the ground, you're about 20,000 feet, and you see a dinner plate on the ground. That's the pixel resolution that we're dealing with. 4 bands in the imagery, the red, green, blue, and the near infrared, and it is in a format called GeoTIFF that lets us put that image in the correct spot on the surface of the Earth. I want to mention something that's very important to me as when I was in the position of Geographic Information Officer, was working with my local government partners. Sometimes they needed higher resolution imagery. And here's what that looked like. See a lot of buy-ups in 2016, mostly going from 1 foot to 6-inch resolution. 2017, kind of the same thing. Hamilton County in 2017 said, no, we want 3-inch. So now the size of a coffee cup top, right? And 2018, some more of that, and we see some more 3-inch, Vanderburgh County, for example. So everybody wins when we share funds to do this, because the data that the state produces and the data that the counties deliver are all delivered to the Geographic Information Office, and I did my best to make those available to the public. I'll tell you one place that you can go get those in just a second. Here's what that data looks like. So this is 3-inch imagery. Notice what all you can see in that. I can see cracks in the pavement. I can see vents in the roofs. A lot of detail. I can see the aluminum light shields on the tennis court. Assessors use this data. People who study floods use this data. Transportation planners use this data. Folks who are interested in water and air quality want this data. And there's lots of other uses too, as you can imagine. Now I want to talk about Lidar, because in Indiana, we've we're working on the second statewide LiDAR project. What is LiDAR? So here's Uncle Jim's LiDAR definition. Anybody ever seen a fish finder back of a bass boat? A few. It is technology in which a sound signal is sent from the device down to through the water to hit a hard surface. It bounces back up, it's received, it turns that signal into an image that represents the bottom of the lake, right? So LiDAR's exactly like that, except completely different. So what LiDAR is sound is too slow, so we use laser. Laser is, there's a laser beam in the bottom, in the belly of an airplane flying up and down Indiana. There's a rapidly rotating mirror that intercepts that laser beam, directs it to the surface of the Earth. We know with great precision the 3D location of that sensor in that plane in space. We use atomic timing, so we know exactly the interval of time between transmission and reception, which gives us distance added to the 3D location of the plane, gives us a really good model of the surface of the Earth. What does that look like? This is one of my favorite images. This is Floyd County in what we call hillshade visualization, but it's nothing more than a solid model of all those XYZ points, millions and millions and millions of XYZ points that we produce through that project. Here you can kind of compare that imagery, that hillshade, to what the map portion looks like. So you can see it's very detailed and precise. Any guesses on what this is? I don't have a t-shirt to give away, but what do you think? So maybe x-ray of your wrist? Yes, sir. Yeah, well, you're very, very, very close. It is the White River. This is just south of Columbus. Notice I've got I did a map. No, I got north pointed to the side instead of up. But these are what are called relics with a CTS at the end. These are historical stream beds. And what we did was took that Z elevation from all those points and we colorized based on that Z. So the higher the elevation, the darker the color. You can see some roads through this image. Those would be higher elevation. The lower the elevation, the lighter the color. Look at where White River traveled over the eons. White River was a get-around. Who knew? Why is that important? Because we need to plan for where we put buildings. It would be best not to put them in harm's way, right? We know that some rivers travel much more quickly than others, and there's a science behind that, and this data helps support that. How about this one? The moon? Going once? Going twice? No. Anybody ever heard of karst? So in southern Indiana in particular, where we have limestone very close to the surface of the earth, it leaches out over time. The Lost River in southern Indiana goes into a karst channel underground. These are just pockmarks left from the years and years and years of that limestone dissolving. How about this one? Well, sort of. It is a Native American mound. So the earth builders who lived in Indiana long, long ago built some of these structures. It's hard to see in that ortho image, though, isn't it? Let's look at it with LiDAR data. I can kind of see what that is now. How about this image? So the ones I've shown up until this one were taken from LiDAR collected by an aircraft. This one, though, is LiDAR that was collected from a van. All of Marion County has been collected in this fashion. So it looks like a black and white photograph, but it's really a 3D image. Cool stuff. It was done with monies that were going to be spent doing a sign inventory. But once you do that, you can inventory all kinds of other things from your desktop. Here is another project, one that I'm especially proud of because I think Hoosiers are cool. Hoosier hospitality is a real thing. We've had a project going on for a few years where I've asked county GIS folks and their commissioners to share their GIS data with me. In particular, point addresses, road center lines, land parcels, and local administrative boundaries. So I was a guy from the state, right, going into a county saying, would you give me your stuff? I got nothing to give you. Well, not quite true, because they got the ortho and the Lidar. So what do you think the success rate would be of a state guy going into a county saying, can I have your stuff for free? A lot of folks said if you get 20 counties to participate, you would be doing pretty good. I'll show you how that worked out in time in just a second. So what we were doing was we said, we want to consume that county data, pull it into a homogenizing machine at the state, turn 92 flavors into one, drop it down into a library, send it down to our partners at Indiana University, make it available to the public from there, all put together in statewide data layers instead of in county data layers. So July of 2008, I sent letters to all the county commissioners saying what I told you already. Would you share? The first county agreed to participate the next month. The last one, so I'm giving this away a little bit, agreed to participate April of 2014. So 100% participation. No one was forced to do that. We all did that because everybody wins when we share data. So this is what that looked like. I'm going to run a little time lapse and let you hear a podcast that someone far away from Indiana took notice of what Hoosiers were up to. So when you first start seeing the map, yellow were those counties that were undecided about what to do. They turned green as the county said, yeah, we'll do that, we'll share, we'll play nice. Along the way, a few counties said, you ain't getting our data. We paid big bucks for that data, you ain't getting it. You can build it yourself if you want it. And you already know the end answer. So this is what it looks like. I don't think I can hear that. Projector.
You can barely hear it up here.
So we're talking about ArcPad, World, Indiana Map, and others. Next up in the news is an interesting story out of Indiana. They have done something that I, working in a state organization, would have thought before now was impossible, but they've gotten approximately half of their 92 counties to agree to join this Indiana One Map system and voluntarily offer up their data into a unified data mapping system and set. The idea is that they do it for free, and then 65% of their population is covered under this map, and you get high quality local knowledge information into the system that anybody can access. So it's sort of leveraging the strengths of the individuals into one really large, impressive piece of work, which hopefully other states will follow, whose example that they will follow very closely.
And kind of like the national map, and hopefully, the national map will kind of take some of this into heart, and maybe it'll even filter all the way up.
Yeah, I think it's a little more.
A little bit, yeah.
I think it makes it makes a little bit more
Sense.
sense to start locally, and think globally, as I say, because one of the things, one of my personal critiques of the national map was trying to get so much into one system. I think that starting with a smaller geographic area of a state may be a little more efficient way to go. Mm-hmm. So it's a very encouraging development, I think, in Indiana. Hopefully it's adopted to all the other states.
Anybody from Boone County?
Integrate that into a national map, and then to buy Coke and make the whole world sing. And
Dare to dream.
Yeah.
Dare to dream.
Marshall, the last one.
Thank you. T-shirt over here. That really is cool. I mean, we're all working together to do good stuff for Indiana, and it is, I think, an example, as these guys said on the podcast, it's an example for the rest of the country to follow, I think. So as a result, we've got about 7,000 of those jurisdictional boundaries I mentioned, almost 600,000 street center lines. Anybody think that automated vehicles, driverless cars will be a thing? Yeah, they might be interested in some of this data, as well as the ortho and Lidar. 3 million address points, over 3 million land parcels. So these are all critical data, and I'll show you some of the ways they're used in just a second. Like right now, benefits. So I'll read this to you. The realization is growing that almost everything that happens in a public policy context also happens in a geographic one. Transportation planners, water resources studies, education subcommittees, redistricting boards, planning commissions, and crime task forces all must consider questions of where, along with the usual ones of how, why, and how much will it cost. GIS, by answering the first question, helps to answer the others. This is my favorite quote of all the stories that I received over the years. This is from David Weiss, who is the Executive Director of the Integrated Public Safety Commission for the state of Indiana. He says, when agencies share data, lives are saved. What more do you need to know, right? And public offices become more efficient. That's a good thing, too. I could have stopped at the first one, but I like both of those. From an economic development perspective, access to reliable local data, GIS data is vital to help us understand how our communities and economy are growing and changing and help us make better decisions. Check out this study. So this was done in England. I'm certain that we'd get the same results here. Question was asked, what kind of data, of open data, is most applicable to the most sectors? And I know you can't read all those. Some of them are, gosh, I don't know if I can read them. Labor market, housing, education, population health, social conditions, crime, planning, businesses. But the tall column, the winner of the bunch, is geospatial. This geographic information we've been talking about. Here's something closer to home. So I asked partners who were using the ortho and Lidar data to send me just a few paragraphs of how they're using it. And I attached keywords and did this word cloud. It is literally from A to Z, from art to zoology. There was an artist connected with the art museum that was doing a project down in the river that used the ortho imagery. So just about any way that you could think of, it has been used. If you just want to talk about dollars, I can talk about dollars. Well, do this first. 86% of users stated that they could not do their projects without this geographic information system out of about 350 respondents to a survey. $1.7 billion supported across the state by these data on the Indiana map. 34-to-1 return on investment. How's your 401k doing? Okay, switching gears a little bit. I mentioned the Indiana map. Anybody ever been to the Indiana map? A few. The rest of you may want to just pop in and check it out. So maps.indiana.edu, maps.indiana.edu. 270 data layers about our state. Most of them can be downloaded. A lot of them can be streamed as map and feature services. Each data is well documented, each data layer with metadata, so you can see if it suits your purpose or not. There's also a built-in viewer as part of the toolkit, so you can look at maps like this wind speed and power map. Anybody been up 65 lately? Oh, actually, 5 years ago or 6 years ago maybe, those turbines started showing up. I am quite certain that someone from that company or those companies looked at a map that looked a lot like this so that they could figure out how to cite those things. Here's a game you can play when you get on the Indiana map. You can set up the ortho and the hillshade Lidar, and you can slide a transparency slider back and forth and see first what the ortho looks like, and then pull up the elevation, the Lidar data. And that's a fun game that you can kill hours and hours with if you're a map nerd. So moving on to a few lessons learned. This may be helpful for some of what you're challenged with from time to time. So back to the picture of me walking into the county offices, right? There were a lot of objections when I first walked in. Things like, this is my data. I'm not sure how people are going to use this data. I don't think I want to give it out. We think this data, this public data, is a gold mine, so we want to sell it. We don't want to change how we collect or store that data. We've got our standards, we want to stick to them. There was a lot of mistrust too, as you can imagine. And a few counties, especially some of those holdout counties that you saw at the end, I think they were mostly concerned about providing imperfect data. But I'm here to tell you, I've yet to see a perfect geographic information data set. There were a lot of wide drivers too that I'm going to get to, but the purpose of this was that an approach that added drivers was okay, but an approach that removed resistors was a lot more powerful, and there's some science behind that. So if you're trying to change the status quo, you might want to think about how you remove resistors even more than you would think about the reasons why someone would want to do that. So in the case of my data, where they said, we want to hang on to it. I requested just a very small subset of the data, and I did remind people, public data is controlled by the Access to Public Records Act in Indiana. Counties don't want to change the format, that's fine. We'll take it as is, we'll do the change in that homogenizing engine at the end. Counties want something in exchange for the data, their data. Sure, we'll do the ortho Lidar and share anything and everything else we've got, and that's what that office has been doing. Mistrust between county and state. How many times have you seen the impact of a meeting face-to-face after you've had some failed attempts at other forms of communication? Walk in, build a relationship, because at the end of the day, that's the most important part of business, is those relationships. So drivers. I spent a lot of time trying to educate folks about how important and beneficial these data are, and you saw some of the stories that absolutely document that. We celebrated successes every time we had one. We got our county partners, our local government partners, as part of the process, and help them own that, and we all benefited from that. Told you I'm a quotes guy. Here's some of my favorites that absolutely have helped me along the way. I've had a lot of folks, especially from other states, say, gosh, Indiana is really lucky to have been able to do all the things in the GIS land that they've done. Well, maybe it's luck. I mean, we've had some for sure, but Seneca, I think this is Seneca the Elder. Gene, Seneca the Elder, luck is what happens when preparation meets opportunity. So we were prepared and we were ready when opportunities did present themselves. Mark Twain, smart guy. The secret to getting ahead is getting started. I've yet to finish a task that I didn't start. And sometimes that's the most important part. Or to say it better, look this one up sometime when you get a chance. William H. Murray, a mountaineer, a Scotsman, an adventurer, who has about a half a page quote that ultimately says, this part of it is the most important. The moment one definitely commits oneself, then providence moves too. You'll find help from all kinds of places you didn't anticipate once you commit yourself to a task. I heard this from an emergency management worker in Georgia. She was their GIS person, and she said it very well, and then I tracked it back. Originally it was said by Ethel Barrymore, but the best time to make friends is before you need them. So I think that's a philosophy of this group, right? Get out, network, make friends. You can help them someday. Maybe they can help you someday. In the confrontation between the stream and the rock, the stream always wins. Not through strength, but by perseverance. It took a long time to convince those county partners to share their data, but ultimately perseverance won out. This is by a famous GIS nerd, famous in this room only. So the way that I look at things is that you really have to focus on, when you're in a group, focus on what you can do together instead of trying to figure out what your differences are and what you can't do. I hold this up as a great example of how all those things can play out. So about 7 years ago, we got a project to map where broadband service exists in the state and therefore where it doesn't. Day one, we had no map. 365 days later, and some bucks, and a lot of cooperation and some good planning, we had a state broadband map which contributed to the national broadband map. You can Google National Broadband Map and see what all those data look like because it's still out there. So the feds said, here's where we want you to end up. Here's some money to help you get there. We're going to kind of control the process, but states, we're going to leave it up to you as far as how you do it. You be the aggregator and the coordinator. And the locals cooperated, they created data, they maintained that data. What else can we do? I'm thinking, how about some other states do what Indiana's been doing? We'll have a national parcel map. You can buy that. It's really expensive, but we've already produced that data. Every state does. Let's just put it together in a reasonable way, or a centerline map, or a point address map, so that we can geocode locations with great precision, right? So the pizza guy figures out how to get to your house. We ought to have a decent geocoder for the rest of us. One more observation. Change is the only constant. So it goes back a ways. So somebody else from long ago. Where are we going with this remote sense data? It is a part of who we are. I didn't have time tonight to talk about locational data privacy, that data collector that we all have in our pockets that knows where we are every minute of every day. Who owns that data? Leave that for another day. So I think I'm going to close the Sparks Circus portion of this presentation and turn the mic over to Kavya.
How many of you have used ArcGIS or is using ArcGIS? Nice. So, have you used Python in ArcGIS?
Yeah. You go around the other way.
Oh.
There's cables here. Oh, wait, here. All right,
Yep.
perfect. There we go. Thank you.
Thank you. So ArcGIS is a geographic information science software application developed by ESRI. ESRI is headquartered in California, Redlands, and it's used for compiling geographic data, processing data, and representing the data on a map, data visualization. So it's a very user-friendly software. Sorry, yeah. Yeah, that's basic about what ArcGIS is. So the Python in ArcGIS is called ArcPy, or however you want to pronounce it. It's a site package which performs geographic data analysis, data management, and map automation. It's a scripting module which provides access to various geoprocessing tools, which I'll show you later, to help us create simple and complex workflows. Basically, the reason why we use Python in ArcGIS is to automate most of our tasks, geoprocessing operations or functions, which are repetitive and which are time-consuming in some cases. So Python helps us automate that and reduces a lot of time. So some of the basic geoprocessing operations in ArcMap, like the clip, if you know already, clip, buffer, or dissolve. These can be performed using Python scripts, and you can and combine all these scripts into one Python script and perform the analysis for various data sets by just click of a button after you create the scripts, which is much easier and cuts down a lot of time. So the way to access Python window on ArcMap is to click on the button in the main ArcMap toolbox or the toolbar, which you can see there, and enter or copy-paste the pre-written script into the Python window. And that's how you execute Python tool. Some of the examples where we use Python in ArcGIS for our projects at the Polar Center include, but are not limited to these, directory setup, creating folders and subfolders for our GIS work, and merge or append geographic layers using their attributes, and create a map document, which is ArcMap document, where we bring in all the layers from the folders and represent them on a map, which can be time-consuming if you do it manually, but using Python scripts, it takes a few seconds to do it. And also convert different formats from table formats from Excel to CSV, or which takes very little time. I'm sorry, I'm not used to using this mic. So the ArcMap,
There we go.
one of the basic examples where we use in our projects is bringing in the layers, like I mentioned before, from the folders and represent them on an ArcMap. So this manually takes about, I'd say, about 30 minutes or so, but using the Python script, it takes a few seconds. What you see here is the ArcMap display, where you see all the flood boundaries, and each color represents the layer coming from each folder. So this is a flood map of maybe a county, I think. So this is very convenient, making script for bringing in the layers from folders and displaying them on ArcMap, which becomes very convenient. The other areas where we use Python are to merge tables using attribute table. If anybody has heard of attribute table in ArcMap, which has rows and columns and displays the information about the layers. So it's using, we use Python scripts to make several calculations, like the statistical calculations and join layers. These are very few of functions that we have been doing, but it's not limited to these only. And these tools can be accessed using Arc Toolbox, which is a feature on ArcMap. User-friendly, just click of a button and it displays a user interface where you can enter the map, enter the parameters, and click OK, and all your processes will be done in a few seconds. So Python is, or has been, very useful in ArcGIS for displaying layers or geographic data on an ArcMap. If you need more information about these geographic processes, operations or processes using Python or even ArcMap, you can visit this website, resources.arcgis.com. If you need more information about GIS and what we do at the Polis Center, you can contact us. Thank you.
All right, I want to thank Jim and Kavya for coming in and giving us a state of the practice of GIS in Indiana. Are there any questions? You guys up for a couple questions if anybody has some questions? So any questions in the room for the GIS experts? These are literally the people. You're talking to them right here. Yeah, are you guys hiring? Question number one. Well, grab the mic up here and let's, be careful going that direction. Go around the other way, that'd be perfect. Yes. Are they hiring? Is the first question.
Yeah, first question, are we hiring? We hire all the time. I know that really what you're asking is, are we hiring folks that are experts at coding? And we don't have an open position right now, but we do a lot of development. For example, we're building a knowledge portal about flooding for the state of Southern California. Southern California, state of South Carolina, sorry. And we're going to be doing the same thing for Indiana here in the next couple of months. And that's a pretty complex task, so stay tuned.
Okay.
Not right now.
We had another question from the middle of the room here. Right there, yes.
Is this what you use to create SAB, like the community profile? Is GIS being used for profiles like that?
Actually, Jim, if you can repeat that question.
Yeah, so I think you're asking how do we create the community profiles? We've got a part of the Polis Center called SAVVY that used to stand for Social Assets and Vulnerability Indicators, but only us old guys still remember that. It's just SAVVY. But SAVVY combines a lot of geographic information and tabular data and looks at it in a visualization that's geographically based to help build those community profiles. And those data sets come from all over the place. I mean, from U.S. Census to State Department of Health to some of the city agencies.
All right, Tom.
Back here. Care to comment on privacy issues for state critical infrastructure that gets blurred out sometimes on the GIS that I've seen?
Sure. Would I like to comment on some important features around the state that get blurred out in aerial photography? I think it's silly. So, for instance, there was, when the first time that we did an aerial ortho imagery project for the state, a lot of people wanted us to blur out water towers. You know, those things that you see when you drive down the street. We did blur out the state or the federal building downtown Indianapolis. You know, that big colorful building that you drive by, or you can look up anywhere else. We also blurred out Camp Atterbury and the Newport installation. That one maybe we did need to blur out, I don't know. But the honest to goodness truth is everybody knows where those things are, especially now. Yes, sir.
A bit of a follow-up then. In this day of drones, would you expect that blurring to continue next time around?
In this modern age of unmanned aerial vehicle systems, would I expect that blurring to continue? No, I don't. But it is a very complex issue. The proliferation of drones in the private sector, that's the wrong way to say it, by hobbyists, is what most everybody thinks of. The use of that technology is extremely limited, and to do it commercially, which is where the bigger concern might be, there's all kinds of stipulations and conditions. For example, you have to have a pilot certified. So a pilot certified to fly that unmanned aerial vehicle system. We don't know how to put together all those little bitty data sets into anything meaningful yet. I'm sorry? Python? Thank you. Let's talk. In INDOT,
I think you referred to jobs earlier, right?
Yeah, right there, right. INDOT in particular is trying to figure some of that out right now. They are definitely interested in mounds of dirt and places where dirt needs to be moved. And they are using a camera system on an unmanned aerial vehicle to do that. And some code that I think they got from a company in Israel. Interesting questions, though.
All right, any more questions? Oh, we got one back here, Anthony. It's your turn, Anthony. You got it.
Thanks, Scott. The perspective of how can we leverage the interest and the knowledge of the community so that Polis Center is not seen more as like an academic, like a grant funded, like
Oh, I owe you money.
and doing something exciting out of this that
Yes, so thank you. Yeah,
So the question, I'll
has to
let,
do with the way that academics works, and there's theoretical academics and then there's applied academics, right? And so the Polis Center is an applied research center. We want to take action with what we do. The questions are interesting, but we want to be able to, it's going to sound corny, but it's the truth. We want to be able to improve the state for the state citizens through action with what we end up doing. So the projects that we're involved with, like better understanding and documenting flooding and planning for that, as an example, are applied, and we expect that they will have a positive impact on communities. Thanks for that question.
all right, any last questions? Well, let's give Jim and Kavya a big round of applause. I want to thank you guys for coming out to IndyPy. Thank you so much.